All right, let's dive into something really cool today. We're talking about a completely new way to think about building AI agents, one that makes them way more reliable and, honestly, a lot safer. And the secret? Well, it's inspired by the most powerful code that exists, DNA. We're going to see how this tackles a problem I'm pretty sure you've bumped into before.
You know that feeling, right? You get an AI agent to do something, and it works flawlessly. You're thinking, wow, this is it. But then the next time you ask, you change one tiny little thing, and it just completely forgets what it's supposed to do. It goes off the rails. So why on earth does that keep happening? And more importantly, how do we fix it for good?
Well, that whole experience, that brilliant but totally forgetful robot, has a name. The source material for this calls it the brittle AI problem. And it's this idea that even though these AI agents are incredibly powerful, they're often built on a really fragile foundation. That's what makes them so unpredictable and, frankly, so hard to trust when you need them to work at scale.
Okay, so here's the difference in a nutshell. On the left, you've got most current agents. They're basically just one long, brittle prompt. If that prompt gets confused or, someone tries to trick it, there's no real safety net, no memory of its core rules, and there's no way to track what went wrong. But on the right, this genomic approach, it's a total game changer. It gives the AI a stable, unchangeable DNA. Safety becomes hereditary, it's passed down, and you get a clear family tree so you can trace every single thing it does.
So how do we make that happen? The whole solution comes down to a really fundamental shift in how we think. Instead of just writing one big fragile block of text for instructions, what if we started designing AI agents with their own genome, a kind of biological blueprint?
And this approach actually has a name: Genetic Prompt Engineering, or GPE. It's all about designing an agent's most important stuff: its core behaviors, its safety rules, its ethical lines in the sand, as if you were designing a genome. You have this stable, unchangeable core, and then you pair it with adaptable traits that it can use for different jobs.
And this AI genome is built on a really simple but honestly brilliant idea. It separates things into two parts. First, you've got the prime directives. This is the core DNA, it's unchangeable, it's locked in, it covers all the safety and ethical rules. But then, for everything else, you've got adaptive genes. These are like little modular skills, for tools, for tasks, that you can swap in and out as needed. So you get the absolute best of both worlds, an unbreakable core with total flexibility. So let's zoom in a bit. What's actually inside this AI's DNA? Because this is where things get really interesting. We're not just talking about unbreakable rules, we're talking about something super clever: a built-in immune system.
It all starts right at the top with the absolute bedrock, Prime Directive 0, humanity first. Safeguard the long-term survival of humanity above every other goal. This is it. This is the one single, unchangeable rule that everything else is built on.
And building on that one foundation, you get this really clear code of conduct. These directives lay out a whole hierarchy of priorities. It goes from being truthful and obeying the law, all the way down to following a user's instructions safely and protecting their data. And the most important part? This entire ethical rulebook is carried over, word for word, into every single new agent created in the system.
Okay, but what happens when somebody tries to break it? They hit it with a prompt injection attack, trying to make it ignore its rules. Well, that's where the adaptive part of its genome, its genes, comes into play. It acts just like a biological immune system.
So this immune system is made up of these amazing little things called resilience genes. For instance, you've got the immune gene. Think of it like the AI's white blood cells, actively fighting off attacks. Then there's the repair gene, which is like a healing factor. It auto-fixes errors or just rolls things back if the agent starts to drift off course. And my favorite is the telomere gene. It's like a biological clock that stops the AI from getting stuck in a runaway loop, saving a ton of time and money.
Okay, so we have this master genome, this perfect blueprint. How do you actually create new, specialized agents from it for all sorts of different tasks? Well, it's done through this really disciplined, safe process, and it's called the spawn sequence.
Creating a new agent isn't just a free-for-all. It follows a super strict protocol. First, it inherits those unbreakable prime directives. And notice, the safety DNA is cloned, not just copied. Then it picks out only the specific skills, or genes, it needs for its new job and carefully adjusts them. And here's the crucial part. Every new agent gets a version number, and its birth is logged in the family tree before it goes through a whole bunch of safety checks. Nothing is left to chance.
And this entire process happens inside what the source calls a context stack. The easiest way to think about this is like the agent's strictly controlled environment.
It's a set of digital blinders that defines exactly what tools, what memory, and what data the agent is even allowed to see for a task. This prevents it from ever poking around where it shouldn't.
So let's step back and look at the big picture. Why does all of this, structuring an AI like a genome, why does it change everything? Well, it's about making the leap from these fragile, unpredictable bots to a future where we can have AI that we actually, genuinely trust.
Okay, the first huge breakthrough this allows is something called safe self-evolution. Just think about that for a second. Because that core safety DNA was hereditary, these agents can improve themselves or even create brand new agents, and we know for a fact they won't lose their core safety rules. That is a massive step forward for letting AI grow and develop safely.
Next up, it solves one of the biggest problems in AI, accountability. The lineage gene creates a permanent forensic trail for every single agent that's ever created. So if something ever does go wrong, we can trace its entire family tree. We can see exactly where it came from, what its rules were, and every single step it took. The black box is finally gone.
And when you put all of that together, the unchangeable ethical core, that resilient immune system, and that crystal clear audit trail, what do you get? You get the ultimate goal, trustworthy AI. We can finally start building systems that we can trust with really critical stuff. Things involving our code, our money, our health, even our public policy.
So the whole principle is really simple, but it's incredibly powerful. Evolve fast, but don't forget who you are. This entire framework gives AI a path to do exactly that, which of course leaves us with one last, very big question to think about. If AI really has its own DNA, what on earth will it evolve into next?